In this question, we have a bicycle traveling at 13 meters per second, and we're given the radius of the wheel. So we know that the distance here is 0.4 meters. And we know that the bicycle is traveling at 13 meters per second. So if you think of the wheel as a perfect circle with a circumference, that circumference is 2 pi times the radius. And if you lay that circumference out linearly on the road, then that's how far, that's the distance that the bicycle will travel in one period. So we can say something like the velocity is distance over time. So the distance will be 2 pi r, and the time is the time for one revolution. So that's the period for one revolution. So this distance here is 2 pi r, and the time it takes to travel from here to here is the same as the time it takes for one revolution of the wheel. So if you remember that 1 over t is just frequency, we can rewrite this as 2 pi rf. And the question is actually asking us to find the frequency. So to find the frequency, you could rearrange and say that's v divided by 2 pi r. So that's 13 divided by 2 pi times 0.4. And that gives you 5.2, and the unit for frequency is cycles per second or hertz. Now, the second part of the question asks for the angular speed or angular frequency. That means how many radians does it cover in 1 second? So that was part A. For part B, what you're looking for is the angular speed omega. That means how many radians does it cover per second? So we know it covers 2 pi radians. 2 pi radians is one revolution. It covers 2 pi radians in t seconds. And t is the reciprocal of f, so we can write it like that. So the angular frequency is the number you just found multiplied by 2 pi. So that'll give you 32.5, and the units will be radians per second. Another way of finding omega, there is a relationship between v, omega, and r. So v equals omega r. So you could have said omega equals v over r. So that's 13 divided by 0.4. And that will give you the same answer. So if you know this relationship, you can use that. If you don't, you can use the fact that the angular speed is simply how many radians are covered per second.